Hello. I'd like to spend some time with you talking about estimation and error. A common thing in the world of mathematics is that we want to estimate a quantity. We're going to estimate function values. So we're going to estimate things of the order like f of x. We want to know what's f of x equal to, and it might be hard to compute f of x, so we're going to be like satisfied. We're going to be satisfied by some value, and let's call that value m. Okay, that's our estimate for f of x. I'm not talking about how we came up with m. You could do that with linearization. We could do that with Newton's method, or a variety of other methods for computing function values. That's fine. We want to quantify how far off were we, okay? Like, so what's the quality of our estimate? What's the quality of our estimate m? How good is my estimate? And we want to quantify this, okay? So the first way that we're going to do that was with a thing that's called the absolute error, or just the plain error, but absolute then completely disambiguates which error we happen to be talking about. That's f of x minus m, and it's the absolute value. So it's how far off were we? I was 0.03 units away. Okay. And so this is just a raw quantification. And say you're like 0.3 units away. That's how far off that was. Is that a lot? Is that a little? 0.3. 0.3 out of what? Like, how big is 0.3 compared to the thing that you were estimating? Is the thing that you were estimating like 0.1 and you were 0.3 away? Then you're like, I was awful, right? But if like f of x was like 1,000,000 and you were within 0.3 of it, that's like a really good estimate, right? So the second type of measurement that we're going to use to quantify is the relative error, which is going to tell me how far away was I in terms of the size of the thing I was trying to estimate. And so that would be the difference between my values over the absolute value of the thing I was trying to measure in the first place. So we call this the relative error. The error relative to the size of the thing that you were trying to estimate. And finally, because we really like percentages, like I'm totally down with percentages. I know what 100% is. I know what 50% is. We might want to give the percent error. So like as a percent of the thing I was trying to estimate, how far off was I? We can do that by taking the relative error, absolute value of f of x minus m over absolute value of f of x. And I'm going to multiply that by 100. So the percent error is just the relative error scaled by 100 to get it into percent world. And the relative error is just the absolute error divided by the size of the thing that you were trying to estimate. So there are these three kinds of errors. In order to compute any of them, you really have to know your estimate and the thing that you were trying to estimate. And that might seem a little circular. And it's like, well, if I knew what f of x is, if I knew what the thing I was trying to measure was, then why was I estimating it? That's a really good question. And it's one that has very deep solutions in the world of mathematics. So there are ways of estimating these things without having to compute them. So we'd like to estimate the error. And we want to estimate these either before finding m or after finding m. There are Latin names for these two things. There's an a priori, error estimate, and a posteriori, error estimate. So before and after a priori and a posteriori. The ways that we do that is really cool. It's a field called analysis. Wow, like numerical analysis is so awesome because it's so incredibly useful throughout science and mathematics. We want to quantify for a model how far off do we think these things are going to be, because if different models are going to generate different m's, there are different ways of computing m, and they have different qualities. Some are going to give better error estimates than others, which are going to give better results, and you're going to choose that one probably, unless it's too computationally expensive, in which case you're going to do something else. So that's what I wanted to say about errors and estimates. There are these three kinds of errors. They're computed with these three formulas. How do we estimate those without actually computing those things before we actually do them is a deep subject in mathematics. Thank you so much for your time today, and I'll look forward to catching you on our next video together. Thank you. Bye.